Good afternoon, everybody, and welcome to Zahn Academy. Today, I'm so excited to have Nick Alonge with us, and he is the Vice President of Xtcera Dental Tools. And he's here to explain to you what a winning combination is in fixed restoratives with Dental Direkt Zirconia and the Xtcera Mill. So we're so happy to have you here today, Nick, and we thank you so much. You're a friend to so many in the industry, and we're honored to have you here at Zahn Academy. So thank you so much.
Thank you, Fran. I appreciate your time and the excitement that we're going to have today.
Definitely. So I know you prepared some poll questions for everybody, and we would really appreciate it if you be very interactive with us. And when we launch them, just give it your yes or no answer. We'd really appreciate it. And Nick also is going to be staying a little after for some Q&A. So if you have any questions for him on anything that we discussed or anything that you want to pick his brain about, just type it in to the bottom of your screen at the Q&A section. So I'm going to turn this over to you, Nick, and thank you again, everybody, for joining us here.
Thank you, everybody. So my goal here is to empower labs to be successful with milling in all digital aspects. So we'll start off today with my little outline. So today we'll be talking about Dental Direkt Zirconias, of course, Xtcera mills, milling issues that you may have had, and of course, Xtcera dental tools that we supply. First, we'll talk out with the Xtcera Pearl Natural Zirconia. The Xtcera Pearl is one of the latest zirconias in the markets today. It offers multiple layers, which is really cool because you can move the unit up and down throughout the disc to get different gradients that you're looking for. It has a megapascal strength of about 1,000 with a 49% transparency. This is a Y3 and a Y6 zirconia, so it's gradient and has different strengths between which size. So the incisal, as you see, is 1,000, and the cervical is going to be at 1,200. So I like this zirconia personally my best for all my anterior work and all the way back to some of the posteriors. I don't usually use it often on full arch cases, but that's what the next zirconia is going to come out with. So some of the benefits here is a natural soft color, highest precision due to distortion, metal free, of course. We prefer it in veneers, inlays, onlays, full crowns, some hybrid abutment crowns, full contour bridges, but no more than 3 units. Some frameworks that are under 3 units, hybrid abutments, but bars, as long as it's under 3 units. Next here is the Cube X2 multi-layer. This is something that we've used a lot in the past. Sorry, I'm a little nervous right now because I haven't done this in so long, so give me a second to compose myself. This comes in all 16 shades, including bleach. This also has a 49% translucent level. It's been in the market for a very, very long time. It's been known to be one of the best in the industries before the Pearl came out. Man, I'm going so fast. I'm nervous here, guys. So this has a megapascal strength of 700, so it's a little bit softer. We sell it both. It's compared to Katana's UTML and STML. Show you some of the benefits of this. It's more stable than lithium disilicate. It contours easier than lithium disilicate. It's preferred in the anterior region. It's got only 2 gradients in it. It's super high translucent. Again, it's designed for these restorations. Wow, I am nervous today. Whew. I'm sweating. Oh, my button's not working. The other one that we have is Cube 1 ML multi-layer. The Cube 1 is a 1,200 megapascal strength. It's mainly meant for full arch cases and implants. It's significantly high translucency with a 45%. It's a Y4 strength zirconia. Its level of aesthetics can be achieved combined with strength. For the Cube X1, you can't go wrong with this choice. There is no hiding the fact that today's zirconia markets has been more accommodatized with overall low barriers to entry levels. This lower price zirconia helps get everybody into the market with the 14mm pucks. We'll move on to what this is all for. It's a universal zirconia that can be used anywhere in the mouth, which is very helpful. So if you need one zirconia in your lab, this is the one I'd go with. It is pre-shaded, so you can just choose the shades that you need and go with that route. again, it's for veneers, full contour crowns, hybrid abutments, full contour bridges, and frameworks. The next is the all-intrusive Bio ZX2 materials. This is something where it's white sheeted material, and then you color on the colors that you want. So it's a little bit more artistically based. It's at 1150 megapascal strength. So it can hold up to a lot of durability. We have 5 different shades that you can color onto it to get all 16 shades that you need. And then the Vita 16 shades on top of that. So you can get very colorful adaptation to this zirconia. So if you need to put in your mamelons, you need to put in a darker cervical part of the crown, this lets you do this. It's beautiful. I've been using this for many, many years as well. It's just a little bit more artistically taken on this. So if you don't have the time to do the coloring, I would not use this material. But if you have the aesthetic and you want to put out the best looking product, this is the product that you want to take on. So this is more of a further similar to a classic zirconia where you do have to colorize it, but it does give you the artistic ability to do what you want with the zirconia. So you have the control to make it much darker if you need to, or much lighter if you need to, add the characteristics that you want to add into this. I've preferred to use this when we're doing full arch cases because and I can colorize every single crown that needs to be done and be able to block out some of the abutments in some areas or add pink tissue to it. So it's very, very versatile in it.
Okay, it seems that 67% of our attendees are happy with the results, but 33% are not.
That's interesting to see. So this would be a good material. These 4 materials would be good to try out to see what your doctors like or dislike about it. And it's a very fair price for testing out materials. It doesn't take a large learning curve. They all can be sintered through the Dikema sintering oven. Dikema has one of the advantages because it already has the pre-level set for each zirconia. So you just go down, pick the zirconia you're using, and it's automatically set in there for you. All right, we'll go on to the next thing. So a good CAD/CAM workflow, is it cost effective? Is it reliable? Is it consistent? And do you get quality results from each thing? So repeatability, are you guys, when you're milling, do you get the same result each time you mill? Or do you have issues sometimes when you mill with, striation lines or little golf ball effects on it or chip margins? There's a couple different things that happen in that. So what to help you get over that is you have to work with the people in your lab. So they're all educated enough to understand the workflow of the digital side, that your equipment is up to par, the best equipment that you can, and the consumables you're using are the best that your lab wants to put out. So I know not everybody wants to drive a Porsche. So some people drive Hondas. So there's that 2 steps there of what you want to consider putting out your best and what you like to do for yourself. So drive easy, drive hard, where that car analogy came from. The tools are susceptible to the environment they're subjected to. The milling parameters, such as RPM, feed rate, chip load, surface speed, how rigidity is your machine, what's the output of your spindle in your machine. All these characteristics change on how fast you can mill something and the surface texture that you get out of it. So with that, we brought on the Xtcera mill. I'm specializing today just on the X-Mill 500. It's more powerful than you guys can imagine for a little bit of box that it is. I've been very, very happy with the results that I've been getting out of the lab I've been helping out with that has a couple of them. So throwing this together, the X-Mill 500 dental milling machine is developed by Xtcera with Horizon integration, key machinery and control components that are the highest in its realm. I mean, they put the best servos in it, the best spindle that's available, the best linear guides, all the sensors in it are top-notch components. So the controller in it is really interesting because what they do is after they put this whole machine together, it goes onto this vibrating table. I think they said it was 50 hours to get all the corks and everything else. They take the shell off, they retighten everything back up, and then they do the quality control maintenance on it, or quality control on it. And the machine is bulletproof coming from the factory. It's been so amazing with each delivery that we've done or that I've been part of, that it's a plug and play. There's no hour calibration or trying to figure out where your tool holders are. It's just you plug it in and it works. It does have an 8 magazines for your discs. It does a 60,000 RPM spindle. I'll get into the spindle details next. Okay. It's a more robust machine than some of the other machines that are on the market these days. So big thing here, we have a nonstop 24/7 working capability. It specializes in zirconia, PMMA, wax, hybrid resin, and soft metals. It's extremely easy to maintain. You just vacuum out all the dust that's inside after each time you take out all the discs. We have a professional sales and service team to help you at all times. We're selling it with Hyperdent these days, but can also be worked with Millbox if you decide to go down that realm. It has auto calibration and tool regulator, so it knows exactly where to put the tools back. It's 5-axis simultaneous milling. It's super accurate, and it's been on the market for, I think, about 7 or 8 years now. So they've had the ability to, if there were any bugs at the time, they were able to get them all out before nowadays. So it's been a phenomenal milling machine globally. My button doesn't want to work. So some of the things here, it is pretty heavy. It's close to 400 pounds. It does require a 200 amp service to run this machine. It has a 1.8 kilowatt spindle rotating at 60,000 RPMs. It has pretty good linear movements on it at 220 millimeters in the X, so it can get really far across. It has 160 Y, so that's well over the 100 millimeter disc that we're working. So as you angulate the disc, you can get into more angles, and 120 vertical Z space movements. It's down to less than a micron in accuracy. So the B axis spins 360, it continually goes around, there's no stopping it. The A axis gets up to 35 degrees. So most of the other mills, they balance out at 30, but the CAM softwares take it to like 27, so you don't overload it. But this takes you to 35, so you can get to like 33 in the angulization angle. So that's awesome there. It is a dry mill only, and it does hold up to 8 tools. So this is a single puck holder. I think I messed up on that one, just to let you guys know it's not a multiple puck loader. They will be offering the multiple puck loader. I think it's the 580. Next, this has a C-clamp that's available for purchase if you want to go that route. And then applications here. Okay, these are all applications that it's really, really good for. Screw retaining crowns. I know Hyperdent's working on a T-cutter that can go inside and do those Powerball screws that we're all talking about, or the Rosen screws. So software has it built in. So if you have that rim that needs to be milled out, they have a T-cutter that goes in and is able to machine that out without having to come in from the Z axis from the top or the occlusal. So I got a little video to show you about the 90-degree milling. It might load, it might not load. Oh, darn. I had an update in Windows, and a lot of things are not working these days, so I apologize about that. So having a 1.6 kilowatt spindle with a chiller allows it to machine a lot faster than the regular machines that are out there in these days. With the chiller that keeps the spindle cool, you can run it pretty much 24/7 if you want to, without having to take that break in between milling long discs. So if you're building a large full arch case, it's always been wise to mill the case, let the machine sit for 40 minutes or so to cool down before you mill another one, because as the thermal expansion happens with the machine, you get less accurate parts. Having the chiller built into the spindle keeps it so chilled that it doesn't expand. So you're keeping that 1 micron accuracy. That's one of the coolest things about this particular machine that I like. These are the 2 parts of the chiller that are external to it. So some of the things here that we always want to do about customer validation, we want to make sure that we're helping you and your labs get the best product that you're looking for. So are your mills not meeting your quality expectations currently? The mills do not handle the high volume that you're trying to do? Are the mills unable to meet the high accuracy demands that we have in our labs? Are the mills unable to mill titanium bars? That's with the 580. Some of the other things here to qualify yourself. Would you like to future-proof your milling? And would you want to be milling it now or in the future? So that's where the price point comes in, is if you have the money to buy this machine or the money to buy that machine, which ones do you go for? Are you going to be doing bars in the future, or is that something you're never going to get into and you're just sticking to zirconia and softer materials? What specific challenges have you had with your current mill setup? Are you getting mismills, chips, all that stuff, which I'll be going over in the future? What level of throughput are you able to put out? Are you taking a crown down to 14 minutes to mill, or are you taking 45 minutes to mill a crown? You know, between those two, one might be a better fit, better surface texture. One might, for your lab, you don't need that. So you're doing a 14, 60-minute crown that you're spending a little bit of time, you know, polishing it up before you sinter it. What level of service do you require? Are you a self-maintained lab and you have a repair person in your lab that can repair your machines, like your printers, your mills, hand pieces, that type of thing? Or do you rely on a third-party company to send stuff out? Or do you have somebody come in and maintain your stuff? So the other thing here is, what type of different financing options are you looking at? Are you looking to pay cash? Are you looking to lease? Are you looking to purchase? Those are different options that here at Zahn, they can help you provide all of that stuff. And I believe there's a special going on right now with Zahn. I don't know all the details, but I'd have you ask your sales reps about what that special may be on these particular mills and products, okay? Will you ask that second question, Fran, please?
Okay, here we go. How happy are you with the outcome of the units coming off of your milling machines? If you wouldn't mind just answering that yes or no. Thank you. So I'm seeing this in real time, and I just want to say that 75% of our audience is happy with the outcome, but 25% are not.
Oh, if we wouldn't mind, for those 25%, would you send us a message of what mills and CAM softwares that you're using, and also the material? Because each CAM software usually has a different zirconia setting. I'm strictly sticking to zirconia because it's easier on this one. For a softer zirconia or harder zirconia, and that dictates sometimes the tool path that's going to be going around. I'll be talking about that as well. So let's move on.
You can put that into the Q&A, say, you know, in regards to what Nick was asking, this is what I'm using, and we can take a look at that in the Q&A section of this webinar and discuss it. Thank you so much.
Yeah, that'd be great. So some of the things we'll be going over here are the typical issues that we have. Number one is chipping. The second biggest one that I come on is surface quality. The third one is fits. And then the fourth one happens is broken tools. So let's go into chipping first. So a smaller tool versus a bigger tool affects a microfracturing of the area. CAD settings affect it. Your collet and run out affect it. Your calibration of the machine usually has something to do with it as well. Followed by, sometimes people overuse a tool. Like if it's, we recommend tools going 100 hours with our settings, working with Millbox and Hyperdent. But I've had labs that have, you know, they're going 150 hours because they want to squeeze as much out of those tools as possible. So they're willing to lose, you know, a $6 crown in order to get that longevity of the tool because they just save so much more money with it. So a lot of times when I'm talking about a small tool chip to a big tool chip, one of the things there, if your largest tool that does all your roughing, if you see crack marks around the outside of the crown, that tool is worn out. So what's going to happen is that as it gets closer to the part itself, those cracks might be bigger because they always leave, you know, a specific distance between the restoration and the next tool that's going to go down to it. So those cracks could blow it out. Whereas a smaller tool, you'll get a smaller little nick like you see in this picture, that this is probably done by the 1 millimeter tool. Just because you can see on the outside of that rim, it's smooth. So that wouldn't be the 2 millimeter doing it. That would be the 1 millimeter. Next, we'll go into surface quality. Are you guys getting lines around the units? Are you getting misalignments from top and bottom from the machine not being around or the CAM software not working together? Is the machine calibrated so that the Z-axis is actually Z0 from both sides, or Y in the right run, or X in the right run, or even A or B, depending on what we're talking about? So the other big one here is run out. So collet maintenance is extremely important. Some mechanical issues can cause this, like a dirty linear guide. So the machine actually like skips along as instead of sliding because it's compacted with material. Or do you have a ball screw that may have a lot of grime on it? So as it's screwing through the, let's skip over that part. It skips as well. Again, overused tools can do this slightly, but it's going to give you more of a golf ball effect or a misfit if the tool is worn out. And then the other last thing could be your strategy settings. Like you chose, this is a bridge here, but you accidentally chose that this is going to be a crown. So it's not going to go around the part the same way. It's not looking for embrasures in a crown fit sitting compared to another. It's only looking for one margin instead of multiple margins. So these are some of the settings where in the strategy, the person sitting there nesting may have accidentally chosen the wrong object and nested it and then went through the process because maybe they are new, maybe they are tired, who knows. But it happens a lot of the times where it's a user error on most of these surface quality stuff by choosing the wrong restoration type. Now, big thing here, fit problems. Majority of the time, fit problems come with machine calibration, tool tolerances, as like you purchased a 1 millimeter and you put it in a 2 millimeter slot, and you can either break a tool that way, or a 0.6 and a 1 millimeter. That happens all the time. Are your CAD settings correct? Do you have the right drill compensations and offsets in your design software? Did you put in the correct shrinkage rate for the material that you're doing? Those are big things that happen all the time. I know most of our softwares want to go 0.3 decibels out. So I would recommend doing 0.3 decibels out. I know a lot of us back in the day would just do like, oh, the shrinkage rate is 20.2. And then you'd go it, and then it wouldn't fit the die very well. And it was actually 0.296. So it was closer to 3, and that's why it didn't fit. So these are just little things that still happen. It's getting better that they don't happen as often. Or somebody will grab a disc that looks like the same disc that we had, and that disc has a different shrinkage rate as the one that they were supposed to use. So just take consideration of taking your time and doing it right rather than doing it over. So a broken tool, a lot of times this is the tool in the wrong slot. The milling strategy is calling for a tool that might be longer reach than what you're expecting, and so you go and you plunge into the material. Are you putting the right material thickness in? I've had it in the lab that I used to run, or a milling center I did. We did 90% of our units in 12 millimeter discs. Every now and then we'd throw a 14 in there, and they would type in a 12. Well, that extra millimeter would snap off the 2 millimeter going into the puck. So it does happen to the best of us. So just to let you know, pay attention to the thicknesses of the discs. Okay. Do you want to go with the next question?
Okay, here's the next one. Do you often get units out of the mill that require time to refinish the surface? You wouldn't mind answering yes or no.
So I got to take a sidebar. Zahn is selling this amazing polishing machine that I have now seen twice. One of my friends' labs invented it, and it is spectacular for not having to glaze your zirconia crowns or your partials or your dentures. It polishes everything amazing. Please ask your sales reps about that particular polisher. I was flabbergasted because I used to do a lot of trainings back when I worked at another company on hand polishing the zirconia because it did a better natural dentition wear than if you'd glazed it. So it's a spectacular machine. I really like it.
So this is pretty cool. 100% of our attendees say no. They don't get units out of the mill that require time to finish the surface, to refinish. So
That's great to hear.
yeah.
That means that their CAM softwares and the machines are clean. That's really good to hear. So next we'll go over some of the tools that Sierra Dental supplies to Zahn. So our first is our most popular, our nano die. It has the advantage of up to 10 times of the original burrs for OEM. We actually grow real diamonds on. So we have a vessel that's CVD, chemical vapor disposition. The carbide tools go into this chamber, and 4 days later, after it gets up to super high temperatures with plasma, the diamonds grow on to the shanks of the tools and give it that special long life coating that we have. We're only one of 3 companies in the world that have this coating machine. And the other company is owned by us. So there's only 2 actual competing companies in the world that I know of that actually do this particular type of CVD diamond specific for dental zirconias. So it offers like a Teflon-like coating that we add into the CVD. So that's why it slips through the zirconia and you get such a better finish off the units in a microscopic level. If you take it down and you look in your microscope, you'll see that our tools on zirconia will have a much better surface texture than our competitors. The other thing here, they're built up in Sacramento, California. So they are USA made. If anybody ever wants to come and see our facility, give me an email. We'll make a plan. I'll fly up there and we can go together, because it's amazing to see the whole process of manufacturing tools and what goes into the details of our stuff. One of the big advantages of all of our tools is we have H4 tolerances on the shanks. It might not mean a lot to people, but if you want to look that up, that tells you how accurate our tools are on the holding side of the tool. So a lot of our competitors buy the blank and they just start working on the business end of the tool, and they don't really realize that if you work on just the business and the shank itself is not completely round, it's going to have a wiggle or wobble in it, and that's called runout. Next, our razor sharp advantage. So this also has the same high-end carbide. What we have is we have a patent lapped edge technology. So I'll show you what that means on the next step. But this is mainly meant for waxes, PMMAs, and polymers on the market. So lapped edge technology is, once it gets ground, you can probably see my mouse here. This is a normal grinding edge that's left on everything. We actually do a secondary process and do a reverse polish from the backside to give it as sharp edge as possible, as you can see here. So there's 2 different edges that go on this that allows it to scoop out the material and cut through the material really, really sharp and quickly. Also offers a longer service life because you're starting with that sharper edge to begin with, and allows it to last longer in the materials. Our other advantage here is our Tyco. So this is a metal milling tool specifically. It's done with a PVD coating that we built and designed in-house, again, with a different coating machine that puts this on specifically for grade 5 titaniums and chrome cobalts. So these tools, from my experience of running titanium bars, I've gotten about 3 to 4 bars out of a set of tools. Now I'm running with, a 8 tool magazine on these. So I'm utilizing lots of different steps, and I'm not taking big, deep cuts when I'm doing these strategies. So same thing, low coefficient. They are good with all coolants, so you don't need to worry about that. They don't rust. They don't contaminate anything. So that's another big advantage for us. And then our grinding tools. So we have high-grade steel cores, and we also do carbide cores. So these diamonds are not grown onto it. They are electroplated onto this. This is actually done in our facility that's in San Francisco. So we do all the shanks in-house, and then we send it to our other facility that's in San Francisco, and they do all the diamond coating for us. What we do specific for us is each size of diameter of tool has a different grain size of diamond put onto it. So an example is the grain size for our 2.5 millimeter is 104, where the grain size for our 1 millimeter is 96, and the grain size for our 0.6 is 83. So that gives it a smooth finish as you finish down to the units. And I'm ready to wrap it up. Do we have one last question?
We do. So I'm going to launch that right now.
Excellent. Here, I'm going to put this up so people can grab my information.
Here we go. So does your milling machine break tools regularly? Yes or no? If you wouldn't mind answering that.
I would suspect not, because 100% of people said that they didn't have to finish any units.
Yeah, which is so great.
That's phenomenal. Like, I have not had that.
And we're going to open things up for questions if anybody has any questions for Nick, as well as if you wouldn't mind typing in the information that Nick asked for the previous.
Yeah, for the 25% of folks, can you please tell me what machines, what CAM software, and what material that you're milling that you're having the issues with? Also, please use my cell phone if you want to text me or get a hold of me. You can email me as well. I work on the West Coast, so sometimes I have an 11-year-old, so I'm not usually starting that early in the morning because I got to get him to school and whatnot. But I'll be able to get back to you as soon as my availability is open.
So also, it seems like 100% they do not break the tools, so that's very good.
That's phenomenal. That's great to hear. That means they take really good maintenance of the machines.
And just one last one, if anybody's interested in adding an Xtcera milling machine to their laboratory. I just want to thank you, Nick, for joining us today. And I just want to let everybody know a little bit about what's upcoming on Zahn Academy. So next week, and that's July 17th, we have Understanding Air Purification and Your Lab Safety with Mark Castanheiro of Quattro Air Techniques. So that's next Wednesday at 2 p.m. Eastern. And then on July 24th, we have Digital Dentures, Lean and Mean with the Power of Lucitone Digital Print. So that's coming up on July 24th. And on August 14th, we have Exploring Pactent's Rodent Titan material with Eugene Rosengord. So all of that is ready for you to sign up. And we'd love to have you join us for the rest of that education now until August 14th. But we are coming to a city near you with our Zahn Dental Road shows, and there is one in Sacramento, California that's coming up on September 27th, Nick. So maybe some of these people would want to take advantage and go on a little road trip and meet you up in Sacramento. That's September 27th. But we are heading to Indianapolis on July 19th and over to Orange County, California on August 9th. So these are our 3D printing road shows. We'd love to have you. It's a day of learning. You get, 6 CE credits, a beautiful breakfast and lunch, and you're learning with your peers. It's really a really great day. So if you're interested in any of our road shows, please go to Eventbrite and sign up for them. We really look forward to having you join us for a day of a lot of fun. This is all of Nick's information, and again, he's such a friend to all of us here in the dental laboratory community, does so much, and he's a wealth of information. So, right, Nick, you don't mind helping anybody out or
Not at all. And it doesn't have to be just milling either. If you need help with CAD design, I can help you with that. Need help printing if you have problems with that. If you need investment help or casting stuff, I know we don't do that much anymore, but I'm willing to do whatever it takes to help us all out.
That's great. We really thank you so much here at Zahn for joining us today and giving us this great information. And I just wish everybody a wonderful day.
All right, guys. Happy Wednesday.
Happy Wednesday.